Okay, so today let's talk about Gibbs free energy. Gibbs free energy is something that scientists use to determine spontaneity. So you can have G equals H minus TS is the formula, or you can remember by agatas, AG AH minus TAS.
Mom went to college.
Yes. So agatas, wherever you have an A, is actually the delta. So it's not changing the formula, it's just another technique or way to remember. So the large delta G is Gibbs free energy, the H stands for enthalpy, and the S stands for entropy. Again, remember that if it's positive, it will be endergonic, and negative is exergonic. And because it's positive or negative, it's irreversible. Likewise, if you have something that's in equilibrium, and contrarily, if you have something in equilibrium, it's going to be a reversible reaction. So usually in textbooks, they show a chart of like positive, negative, negative, and it gets confusing. So just remember, like, if you have a negative H or an enthalpy, that's favorable. And if you have a positive S, that's also favorable. So you have two things going in your favor, so it's always going to be exergonic. The other way you can do it is mathematically. So you have here negative and a positive here. So the negative times the positive will be negative. So a negative plus a negative is negative. So it's always exergonic. Then if you have the opposite situation where you have a positive enthalpy and a negative entropy, it's always going to be endergonic. You can apply the same math. If you have a negative times a negative, it's a positive, and a positive plus a positive is positive. So it's going to be always endergonic. Then you have the situations that are in between. So you have a negative enthalpy and a negative entropy. So again, if you have a negative times a negative is a positive. But if you make it a low temperature, then it's going to be a smaller positive. It's like, for example, if you have like a negative 2 and a positive 1, the negative 2 is still going to be more, a higher portion than the positive 1, so it's still going to be overall negative. So if that does not make sense, just remember you want your negative to be greater for it to be exergonic. So you want the positive to be less, so you need a lower temperature. And the other situation, if you have a positive enthalpy and a positive entropy, remember that if you do a negative times a positive, it's negative. So you want that portion, the negative, to be higher, so you need a higher temperature for it to be exergonic. I hope this helps.